and welcome to example number 2, where we are going to be looking at pizza. So here we have the fat content from two different, saturated fat content, sorry, in grams of several pizzas sold by two national chains, and we want to know if the two pizzas have significantly different means in saturated fat contents. So I'm hoping you look at this and notice that my samples are two different sizes, and it's raw data, which means you need to type it into Minitab, which I have already done to save us a little bit of time. And now I'm going to set up my hypotheses. So my null and my alternative. And this looks very similar to what we've seen before. We're just looking for, is there a difference or not? So what I want to know is there a difference in the means? So we'll throw a mean on there. So we're asking, is the mean for brand D minus the mean for brand S? No difference whatsoever. So, sorry, PJ equal to 0. And so for our alternative, we're going to want to know, are they different or are they not equal? So we're going to replace the equal sign with a not equal to. Because again, we're just looking for a difference. We don't care in which direction. Okay, so we are on to step number 2, which is looking at the model. So I need to check my assumptions and conditions. So the first thing I want to do is I want to see, are they independent and random? Well, that's not really given to us in here. It's just several pizzas by a national chain. So there's no way for us to know if those two conditions are met. So we will need more details to tell if the samples, were random and independent. So failure that one. Okay. Next up, what we want to do is check the 10% condition. There are lots of pizzas sold in the United States, and even for just two national chains, there's lots of them sold. So this is probably not more than 10% of your sample. So I would say that this is less than 10% of the population. Check on that. And now we need to check nearly normal. So in order to do that, I'm actually going to use Minitab. For the previous condition, we actually had descriptions of the sample, description of the population, but for this one, we don't have that. But we do have the data itself, so we can do histograms and check to see if they fit normality. So we're going to go up to graph, and then down to, graph, and then down to, where is it? Oh, histogram. One thing I enjoy about Minitab is the tiny pictures that let you know, like, what to do, where, and how. So there's that. And I just want a simple one. I'm going to go ahead and hit OK. And the variables I want to graph are D and PJ. It's going to ask me a bunch of stuff. If you want, you can go ahead and make some selections here, like maybe you want to label it and a bunch of other things, but I don't really care about any of that. I just need some basic histograms to see if they look normal. Come on. There we go. So there's the histogram of PJ, which does not look very normal. There's the histogram of D, which kind of has some symmetry, which is good. Yeah, and it's got a peak. So D looks more normal than PJ does. This one looks way worse. Hold on. So I'm going to copy these both into Minitab, and I think I'm going to pause while I do that. Okay, we're back. So one of the things I don't like about the histogram for PJ is it's not very clear what's going on. It's on a much shorter scale, and I think I'm going to bin this differently to get it to be a little bit more accurate to what the shape is. So how you can do that is if you click in the gray space, you'll see an option in here. Where is it? Edit bars. Binning. There it is. So it asks you for the number of intervals, and right now it has 9, so I'm going to actually reduce this to, I think well, that's a little annoying. I'm going to reduce this by half. I'm going to be like, let's do 6. There we go. Now we're getting a much better picture of this. So I reduced it on purpose to try to get an idea of, is this looking normal or not? And I think this gives us a much better picture. I'm going to copy this back over here. Knowing when to do that's a little bit more of an art than a science. 6 is probably too few, actually. I should have probably did 7, just reduce it a little. But hopefully it's making it clear that they both are unimodal. One is symmetric, one is not, but we're going to be okay with it for now. So unimodal, symmetric, and this one is unimodal, and it looks skewed. So we have a little bit of a problem with this second one, and a big problem with the whole I don't know if it's independent random. But we're going to go ahead and do this test anyway, even though you shouldn't probably. At this point, I'd be going back to the drawing board asking for more data for this one to see if I can get a little bit more normality out of it, and wanting to know, like, hey, is this good data with the whole random and independence-ness. But, you know, can't be perfect. Let's do some stuff. Okay, so I've got my histograms, I've checked all my stuff. Let's get mechanical. So we're going to go up to stat, basic statistics, over to sample t. And this is still set on summarized data, but I'm not using that. I'm actually using each samples in its own column because there's sample 1, there's sample 2. Woohoo! So sample 1 for me is going to be D, and sample 2 is brand PJ. Come on. There we go. I'm going to check my options. It's still a not equal to test. I still think the difference is nothing. They're the same, and my confidence interval is 95%, so we're good to go. And here is the results of my test, which I'm going to copy over for my mechanical section. Ooh. Sample T. All right, now let's write ourselves a conclusion. So you look at this and you see the super tiny p-value and the fairly small t-value. Look at your degrees of freedom. There's not a lot going on. It's clearly positive, which means that brand D is clearly higher in saturated fat from what we're seeing because the entire confidence interval is positive. Let's write our conclusion. So the evidence suggests that the average level, or should I, let's do amount of saturated fat in brand D's pizzas is higher. Well, I shouldn't say that. I'm going to say different because that's the test I did. I should have tested for higher because it looks like it's higher than the average, oh, this is me being lazy, average amount of saturated fat in brand PJ's pizza. With a p-value of, where is it? 0.000. Oh, well, that's like a really good one. Okay, so on average, one is higher than the other. If you want to be more specific than that, then at this point I would bring in the confidence interval to give me an estimate for what the difference actually was on average. Remember, this is on average. It's not the actual physical difference, and it's a range of values as well. If you're looking at this estimate for the difference up here, sorry, what that's telling you is if I was looking at the average distance on average between them, the average difference on average would be about 4.7. Additionally, if you want to look at this confidence interval junk and need something off of it, like, oh, there's the standard deviation for just brand D. There's the standard deviation for just brand PJ. Yay! And remember, SE mean, that's standard error for the mean, so these are the spreads accounting for sample size. Fun facts. Alrighty, that's all for this video. For example 3, please stay tuned for example number 3 video.